Okay, here we go. So 5. So again, you can fill these in on your thing and get the right answers. So number 5, right here. So number 5 goes, the substances present before a chemical reaction takes place are called the what? What do you think? What are they? So number 5. So yes, so reactants. So make sure you read that with me. The substances present before a chemical reaction takes place are the reactants, right? Yeah, so you just write the answers in your, yeah. And then this is due at the end of the week, all 49. What I have up here. And the substances present after the reaction takes place are the what? Products. So I can keep these up here while we do the rest of the questions. Because remember, we're going to identify the reactants and products. What are you doing? All right.
What are you doing? Team swag.
So 5's easy, right?
Yeah, it is.
Reactants, products. But you got to know that to figure out these answers. All right, so we're going to do 12. All right? So read with me because, again, these seem hard, but they're actually not. So 5 is done. So we're going to do number 12. So just follow with me and you'll see that they're actually quite easier if you understand what you're doing. So solid ammonium carbonate is used as an ingredient in smelling salts. When solid ammonium carbonate is heated, it decomposes into ammonia gas, carbon dioxide, and water vapor. Write the unbalanced chemical reaction equation for this process. So what's reacting?
NH4.
So we got ammonium carbonate. So we'll go solid. So solid ammonium carbonate. Is there anything else reacting in this? So they give us the equation for this, but if most of the time they won't. So ammonium is NH4 plus, right? You know that from your polyatomic, right? What's carbonate? CO3 what?
2.
No, minus 2. So ammonium carbonate, most of the time you're going to have to figure it out yourself. So you have to do the crossover method. And so you got NH4, 2CO3. So is that easy? Do all of you know how to find that? Ammonium carbonate?
Yeah.
If it wasn't given to you. All right. So is used as an active ingredient in smelling salts. When solid ammonium carbonate is heated, it decomposes into ammonia gas. So ammonia gas. What else? What else? What other products? Carbon dioxide. Gas. What else? And water vapor. So, and keep in mind you can't fill all this in the box. Like in the box, I just want the final answer. So use scrap paper. Use the extra paper I give you or something. So we have the reactants, and we have the products. Ammonia gas is NH3. What's carbon dioxide gas? You guys know that. Carbon.
CO2.
CO2. Di means 2. Water vapor is what? H2O what? H2O what? No. G. Water vapor. So vapor is gas. So from here, all we have to do is rewrite it. So if you determine the reactants and products, and you don't have to do this for everything, but for, fine, yeah, you can do it for everything, that's fine. So the final answer would be NH4, 2CO3, solid times NH3 gas plus CO2 gas plus, sorry, H2O gas. So that's the answer. So that's not too bad, right? It says write the unbalanced chemical equation for this process. So you're going to get somewhere you're at, you don't have to balance it. So is this balanced?
Nope. No.
What's one compound that's not balanced? Or what's one element that's not balanced?
Hydrogen.
Yeah, every element's not balanced. There's not one element that's balanced. So nitrogen, that distributes in there. So NH4, 2 is technically going N2H8, or if you want NH4 plus NH4, which is N2H8. You have two ammoniums. All right? Kind of make sense? I think this you guys will get this, but I bet you this makes some sense, right? We did 1, 5, or 5, 12, and 33. So we're going to do 33. So balancing equations. So again, we got all week to practice. You got to practice some of this on your own too. But so we'll do 33. So the balancing equations. We got 33. How much time do we got left? All right, we got enough time. We got enough. All right, balance each of the following chemical equations. So A, especially for people who don't know this well, this will help them because we're sort of starting over at the beginning. So we got H2O2 aqueous, so hydrogen peroxide aqueous, breaks into water, liquid. Xavier, stop.
What am I doing?
You're doing something. Plus O2 gas. All right? So right now, the first step here is this balanced already?
No.
So what's not balanced?
Oxygen.
If I were to go like this,
Oxygen.
and we were going, how many hydrogens are there? How many oxygens are there? How many hydrogens? How many oxygens? How many hydrogens we got over here?
Two.
2 oxygens? 2. Now how many hydrogens do I have over here?
2.
How many oxygens? 3. Does that make sense? So we got to do something. So you need to get another oxygen on this side. So you got to go through the process. Does anyone have it figured out without 2, 2, 1? 2, 2, 1. So we got 4, 2.
No.
Yep. So 2, 2, 1. So it's sort of a process here. So you know hydrogens are equal here. So you're going to need the same number here and here. And you can do trial and error. So especially at the beginning, do trial and error. But you got to look for little clues. There's not too many clues in this one though. So now if we put 2, 2, 1, we now have, so remember this distributes. Like that. Or this is also saying 2 H2Os, O2s. Technically it's saying that. So now hydrogens, we got 4. Oxygens, we got 4. Does that make sense? You good? On this side, remember that distributes, that 1 distributes. Hydrogens, we have 4. Oxygens, we got 2 here, we got 2 here. Alright? So do you see that balances? So that's a good first step if you're behind on the balancing. But do you see that this balances for students behind on the balancing? Yep?
A little bit.
Alright. So let's do, that second one's a little bit easier where they show the tricks, like in it. So we got 5 minutes. YouTube only lets me upload 15 minutes.
Hey.
Alright, so that's A. B, you can see some of the tricks here. So we got silver solid plus 2s gas blank Ag 2s solid plus blank H2 gas. Alright, so let's go through the thinking process here. So this is where, so students struggling with this is a good problem to, so guys, this is a good problem to see how you figure out how to balance equations. So how many silvers do I have on this side? How many do I have over here? So what do you think I'll put in front of there? 2. So at that point, if I put a 2 in front of that silver, we can't make that any bigger, right? So that's going to be a 1. So how many sulfurs? Yeah.
Can you say that again?
So there's 2 silvers on this side, and there's only 1 over here, right?
Right.
So to make this side 2 silvers, we just put a 2. And then now it's balances, right? Right. I know. So yes. So you just put a 1 there, because now those silvers balance. But how many sulfurs do I have on the product side? 1. What should I put here to keep that 1? 1. So now how many hydrogens do we have on the reactant side?
Oh, I'm getting it.
So what should I put in front of that to keep that 2?
1.
1. Right. So in the end, especially when students first start, all chem teachers go like this. Make sure that everything balances. Eventually, you might not have to. So we got 2 silvers, 2 hydrogens, 1 sulfur. We got 2 silvers, 2 hydrogens, and 1 sulfur. Make sense? So that's A and B. All right. So C and D. I'm gonna have to stop.